All right, so we're talking about plate tectonics today. So, Derek, what do you know?
When tectonic plates move, they cause earthquakes.
All right. Marcus mentioned when they shake or tremble, they can cause earthquakes as well. Garika.
Uh, the plate tectonics are basically the crust of Earth broken into giant slabs of rock.
All right. Audie?
When they move towards each other, they could form mountains, and sometimes when they crash against each other, the earthquake that happens could also form a tsunami.
Okay. Armand?
Plate tectonics are pieces of Earth's crust floating on the mantle.
All right. Let me take a look at what you guys wrote on your formatives. Any other volunteers? No? Let me take off your names here and show off your work. So pieces of Earth crust float, cause earthquakes. Let me try to expand this a little bit better. There we go. Give our planets heat when the sun hits them. Okay. Shift the Earth's ground, shaking. Solid crust, boundaries. We're going to be talking about boundaries today. We're going to be talking about tectonic motion. We have a quick video, causes earthquakes, lots of earthquakes. We are in California, we understand that. Although I don't think you guys have really experienced a strong earthquake yet. It's been a long time. Yes or no? Have you guys felt an earthquake in your lifetime? Click yes or no. I believe we had probably like a 4 point something not too long ago. Yeah, okay. So I remember when I was in elementary school, that's how long it's been. There was like a 6.7 in the 80s, right? In the 80s. So we're due for another large earthquake soon. So that should be fun. Okay. All right. We have a video, and during this video, they're going to bring up a lot of vocabulary. And I want to encourage you to add to your notes. If you need to unsubmit your digital notebook and resubmit it, because again, I am going to grade those today, feel free to do that. Ignore any kind of late message. Or if you're doing pen and paper, then we have this here. Okay, so let's go ahead and enjoy this video, and then we will.
Enjoy this movie, then visit brainpop.com for much more. Are you sure this thing is rated for this depth? You bought it from an Airmall catalog. Oh, great. Dear Tim and Moby, when I look at a map, it seems like some continents fit together perfectly. Are my eyes playing tricks on me? From Georgia. You're not seeing things, Georgia. Some continents look exactly like puzzle pieces that snap together. Early map makers suspected that they were once all connected. In the early 20th century, a scientist named Alfred Wegener called this supercontinent Pangaea. He thought different chunks of it broke off and slowly moved apart. Over millions of years, they formed the continents we know today. Wegener couldn't explain why Pangaea split up or how. But there was some evidence to support his idea. Fossils from similar plants and animals had been found oceans apart. The age and type of rock layers matched up too. Wegener's theory of continental drift provided an explanation, but his ideas weren't taken seriously until long after he died. In the 1950s, scientists began mapping the Mid-Atlantic Ridge. It's a mountain range running 10,000 miles along the ocean floor. Tests revealed that the farther you got from the ridge, the older the seafloor was. So a geologist named Harry Hess proposed a revolutionary idea. New seafloor was forming at the ridge and spreading outward to make room for more. In other words, the surface of the planet was moving. Hess called this process seafloor spreading. It seemed to indicate that rock was being forced up from inside the planet. Nowadays, we can see this rock formation in action. Wegener had guessed something like this, but he had no way to prove it at the time. As he suspected, there's a lot going on beneath the Earth's surface. Up here, everything seems pretty cool and stable. But miles below our feet, it's a raging inferno. The deeper you go, the hotter it gets. Earth's center, or core, is as scorching as the surface of the sun. All that energy wants to escape, like steam inside a boiling kettle. It pushes outward, putting immense pressure on the middle section, the mantle. Standing in its way is the lithosphere, a rigid layer of solid rock. Well, the lithosphere isn't like a smooth shell. It's cracked into pieces, each one a different shape, size, and thickness. We call those pieces plates. Yep, the mid-Atlantic ridge is the border between several plates. They're being dragged apart by forces from deep inside the planet. You can think of it like a pot of soup. The Earth's core is the burner, and the mantle is the boiling soup. As the soup near the burner heats up, it becomes less dense and rises. When it gets to the top, it cools off and sinks down toward the heat. In physics, those are called convection currents. A similar process is driving the mantle, and it's taking the plates along for the ride. That movement is called plate tectonics. It's the engine driving the constant transformation of our planet's surface. Plates have been bouncing off each other for eons. The oceans have expanded and contracted. Land masses have smashed into each other and broken apart. The plates move about as fast as your fingernails grow, so we don't see the ground sliding around under our feet, but we do sometimes feel it. Yep, I'm talking about earthquakes. Seismic activity is greatest along plate borders, at convergent boundaries where two plates collide, at divergent boundaries where they pull apart, and at transform boundaries where they slide past each other. At all three boundaries, there's enormous pressure on the Earth's crust. That's the topmost layer of the lithosphere. The pressure can build up for years. The longer it takes to release, the bigger the earthquake. Yep, and plate movement drives volcanic activity, too. At divergent boundaries, like the mid-Atlantic ridge, there's a gap in the lithosphere. So magma, molten rock from the mantle, is constantly pushing up along the boundaries. These are the most volcanically active places on Earth. Volcanoes are also common at boundaries called subduction zones. That's when a dense ocean plate converges with a lighter continental plate. The heavier plate gets pushed below, down into the mantle. Some of it melts, and the magma erupts farther inland. The Ring of Fire is a massive chain of these volcanoes. Dense sedimentary rock making up the Pacific seafloor is subducted, transformed into metamorphic rock through pressure and heat, and then recycled as igneous rock through volcanic eruptions. In other words, plate tectonics drives the rock cycle, the constant process of transformation and renewal of the Earth's crust. It also creates our most prominent geologic features, mountain ranges. That happens when two continental plates converge. Since they're both about the same density, neither one subducts. Instead, it's like a slow-motion car crash. The plates buckle and warp. The land pushes up into jagged peaks. The Himalayas are still growing from a plate collision that began 500 million years ago. Yeah, Alfred Wegener's theory has come a long way in 100 years. He was practically laughed out of the scientific community for his ideas. But today, plate tectonics is the unifying theory that ties together the entire field of geology. What do you mean, out of juice? We're stuck here? Ah! Now what? Oh, thank you.
So hopefully that was a good refresher. Hopefully you took some notes on that. We are going to go into great detail with that probably on Thursday. But let's take our first break. And apparently, well, when we get back, we'll talk about it. 3 minutes. Ready? Get a snack, stretch. Hopefully the internet gets better. All right, come on back. One of the major things we know plate tectonic does is it moves the plates of our planet around, causing earthquakes. And you guys mentioned, oh, we had one last night. We just had one right now. You're right. We're having earthquakes all the time, actually. But they're so small that we normally don't even notice them. Okay. Especially if you're moving around and doing things, you may or may not even notice. So it has to be a pretty strong one, usually more than a 4.5. You will notice that motion a lot better than the smaller one. So yeah, we're definitely having earthquakes every day, all the time, which is good because it's relieving a little bit of the pressure in our plates. We want it to constantly release a little bit at a time. It gets worrisome if we don't have those little earthquakes because that means the pressure is building up and it's going to release a lot larger than we want. Okay. So again, thank you for letting me know that you are back, Marcus. I should see or hear from Bailey, Faith, Angelica, Derek, Izzy for this one here. All right, so this is what we're going to do. You get to explore with the, thank you, Izzy, with this gizmo of plate tectonics. let me put this link in the chat box actually. It is also attached to the assignment on your Google Classroom as well, okay? Now, I took out the questions about the drawings. So only answer, let's see, where are we? The formative, this one. Okay, you should have 1 and 2 filled out already. I do want you to work in groups, and I know you guys don't like this. Too bad, okay? You guys need to interact with each other. So we're gonna have a discussion leader. We're gonna have, again, a screen share. Okay, Bailey, just let me know that when you're back on. Groups are random, okay? Time manager. Now, a reporter. Some of you are gonna have groups of 3. So you might not have a official reporter. So you all need to share these requirements, okay, or expectations. All right, when we get to the formative, there are some questions. Let me scroll up even higher to where I deleted those. Why are they still there? I'm going to delete these questions about drawing what the plates look like. So while you're doing the actual warm up, you're going to see these blank here. It's just skip them, okay? First period was getting frustrated because it was taking a lot of time to do the drawings. And I'd rather you draw in your notebooks anyways. So when we actually take notes on this on Thursday, yes. When you take notes on this in your notebooks on Thursday, then we'll worry about drawing. I don't know why it's still there. Oh, you know what? I bet you. There we go. Let me see. Yep, perfect. I already deleted them. So you are going to skip the ones about the drawings. So you only have a few questions to do. My goal is you can get this done in class today. So, questions for me? Okay, let's set up those breakout rooms. And you're going to have, I'm going to make them smaller. So I'm going to try to keep them to 3, 4 people maximum in your groups so that you can actually talk to each other. Okay. Let's see if that works. Okay. All right, let me shuffle a couple people around. Go ahead and try to open up the Gizmo link. Especially with the internet, it's kind of, it needs some gentle words. So talk nice to your internet today. Encourage it to work as best as possible. Okay. All right. You need a screen share. That's going to be very important, especially if your internet's kind of wonky right now, so that you can ask your teams any questions. Okay. All right. Have fun. And see you in a little bit.